I need everybody to check their notes for assignment 10.1. I think we left off having discussed strategic metals. Did everybody see the strategic metals list?
Yeah.
We did? Holy mackerel, we're back there, the three weatherings.
Yeah, we're pretty strong.
Wow, all right. Study goal number 12 is a vocabulary distinction. A resource is anything that we want to use from the earth, but a reserve is something that we know is present in an area. A reserve is something that we know we can reach. Like cereal is a resource, but that box of cereal in my cupboard next to the bread is a reserve of cereal. Because I know where it is and I know how to get to it.
But they're not used for like mining purposes?
A resource is the fact that it has value. It's something that exists on this earth. So there's cereal in the planet, and it's something I want to eat. That makes it a reserve. That makes it a resource. That is something that I know has value that's out there somewhere.
Okay.
But a reserve is like a clump of that, a volume, a given spatially determined amount of it someplace. 13, I'm hoping, is just a vocab. It's just a simple, kind of obvious thing. If your resources are finite, you can't keep using them forever. Number 14. If you were going to pick a country anywhere on the world map, that's a pretty good choice right there. As far as the world map goes, the United States is kind of sweet. We have freshwater, groundwater, a variety of biomes. We have a ton of different mineral resources. We have energy resources. We have lumber. We have fish. It's a pretty sweet chunk. A lot of people argue that any imperialism and colonialism stories aside, America's current global position has a lot to do with the fact that it's just a really sweet piece on the map. If natives had kept it, or Mexico had kept it, or France had kept it, it would still be a world superpower because it's a beautiful piece of dirt. But there are a few things that we really need for our economy that we can't get here. Those are called strategic resources. Resources we need, but we can't get on our own map. That's called a strategic resource. And these are the 6 most critical strategic resources to the United States. Things that we need for our economy, but we don't have here. You know, speaking of international relationships, the United States is a global superpower, but that kind of makes sense because we have like a really huge military industrial complex that supplies weapons all over the world. We have a bunch of like graduate schools that build our intellectual capacity. We have a bunch of physical resources that make us a productive economy. We design things and we build things that we export all over the world. So it's sort of, you can explain why America is a modern nation. But how the heck does Kazakhstan stay a country? They're like a pretty modern. It's not like racist jokes about deserts and stuff. Like Kazakhstan is like a pretty nice, like, you know, well-educated, you know, all of the, you know, fancy cars and cell phones and like nice houses and cool clothes and there's like culture and fashion and all that.
Borat.
Yeah, there's Borat. Kyrgyzstan, like I don't even know where that is. And Kyrgyzstan is like a pretty modern, like normal, happy country. How do these countries stay in business? What does Algeria do? Where even is New Caledonia? Yeah.
I'm just guessing that like if they have a good relationship, so they have they just export out.
Bingo. But they're not exactly banana republic in the agricultural sense of the meaning of the word. They are a resource banana republic. They've got like huge mines of. Russia is the world's leading nickel producer. New Caledonia is the second biggest producer of nickel on the planet. Australia, Guinea, and Jamaica are responsible for like 80% of the world's aluminum. So like every time you like get into an airplane or a car, okay, that's Jamaica money right there. I mean, if you think about it, like, I don't know if you've ever visited Jamaica, like, it's surrounded by some really poor nations. That's like a really rough part of the world. And Jamaica's like super modern and like, it's all globally relevant. That's because like, I don't know, I forget the exact number, you should Google this someday. But something like 80% of government spending comes from taxing their export of aluminum. Did it with Australia. Like, there's a lot of countries that you just kind of like, on second thought, how are you actually a country? And it turns out that they are strategic suppliers. So we protect them. Like, what do we have in common militarily with Kyrgyzstan and Algeria? But they're like people that we protect militarily because, you know, they give us stuff that we need. All right. There is a kind of new strategic material globally today called the rare earth metals or rare earth elements. Yeah, bro?
Those are in like,
Rare earths?
Yeah.
There's one there. I think you're thinking of, what's that called? Coltan?
Yeah, for cell phone.
Yep. Well, that's one example. I don't really know where coltan is.
It's in Congo.
Oh no, I know where it's found on the map. I mean, I don't know where it is on this. Does anybody know the abbreviation for coltan so I can stop looking? Can anybody else see it so I can stop looking?
Oh, CS, I think. No. There's no CS. Yeah, there is.
Yeah, there is.
Up next. That's easier.
Where is that rascal coltan?
How do you spell cold?
Is it not an element?
No, I'm pretty sure it's a mineral.
It's a mineral maybe?
Yeah, I think it's no.
Must be, because I've just skipped this like 18 times and I still haven't seen it. Anyway, look at me. There are some things which are rare on the planet, but in this age of cutting edge electronics, we got to make better batteries, smaller and lighter cell phones, fancier, brighter displays. And so, there's this exploding engineering discipline making new materials out of new ingredients. All this stuff here is relatively rare. Like those are pretty common. But as you move down and central, some of those are really hard to find. There's exceptions. There's exceptions. Some of these aren't that rare. You know, like silver, technically, globally, there's actually kind of a lot of silver. But some of these are really, really rare. And it turns out that in very, very small numbers, they can really revolutionize the world economy. Imagine how much money Martin would make if he could make a cool Android device. Or imagine how much money you could make if you could make a cell phone that lasted, the battery lasted longer or whatever. There's a lot of development going into using these things called rare earth elements or rare earth metals. REMs and REs. Rare earth element. Technically, not all of them are metals. We usually talk about the REMs because the ones that we use the most are rare earth metals, but there are a couple of non-metallic rare earth elements that are also useful. So you'll see these used interchangeably. They are rare things on the periodic table that have a lot of economic potential. And up until the wacky liberals ruined everything, the United States used to produce these in large numbers. But when we decided that we wanted to protect our environment, we sort of had to shut down our rare earth element mines in the US. And look who else has deposits. This is one of those things that you'll hear in my class where I tell you, I know I'm onto something. I know I'm onto something. Everybody's worried about how China, quote unquote, holds all the debt to the United States. That doesn't really mean anything. Don't worry about that. I mean, I know that people are really worried about it, but I don't think it's a big deal. And everybody talks about how, like, China has a whole bunch of people, so, like, if they all picked up arms, they could be a hell of an army. Nah. And everybody talks about, like, all these reasons you should be afraid of China. There's only one reason that I'm afraid of China. They are the leading maker of electronics. They've more recently become the leading maker of engineers. Their educational system is making all the people that make all the electronics. And now, they essentially monopolize the world's supply of rare earth metals. You all realize what the economy of the future is, right? Like, the only thing making money in the economy in the long term is electronics. You all realize that? So as I told you first, it's the rare earth element thing. If you do a little Googling on China, rare earth elements, strategic metals, economic forecasting, you get some really panicked economists. It's like a really touchy subject globally. The Wikipedia page is like one of the most edited Wikipedia pages of the last couple of years. The rare earth elements page, rare earth metals. Because it's such a touchy subject, it's like a really hot topic. A lot of people have something to say about it. You know, Wikipedia is edited by the community, right? For Wikipedia, you know what that means? That users can all modify those global information.
They tend to get like, aren't they changing it kind of like they want to like they have to put
Yeah, they have them stand over what you do.
Wikipedia? Yeah, it has to be edited, yeah. Yeah, it is a managed page. Okay. But whatever. Number 15 gets 3 stars. And I gotta warn you that this exam relies heavily on the stuff in class and in the reader because the book didn't have a lot of the information I wanted to talk about. This study goal shows up on the exam, I'll tell you that. And I wish I could finish it today, but I had a nagging feeling that I'm just barely going to scratch the surface. There's 5 different types of mining, but they all share the same few problems. So I want to talk about mining in general before I describe the 5 types. First of all, keep in mind that mining globally has become a very large-scale job. The type of mining that most of us think of as mining is mining like 200 years ago, not in the present. The idea of people with like headlamps and like overcoats and like shovels, like digging holes in the ground and like donkeys pulling parts and stuff, that's over. That's been over. There's some vocab you gotta know. Spoils is the dirt you moved when you're digging the hole. So if I'm trying to dig up a dead body, the dirt on top of the corpse is the spoils. It's the pile of dirt you make before you hit the target. And tailings is what you get when you clean up the ore. Look over here. How many of you know what that is, ore? Stop writing for a second. Stop writing for a second. I want you to use your memory, and you can't remember things well when you're doing another thing actively in the present. Y'all remember the cookie mining thing? Where you pulled up chunks of cookie that had chocolate chip in them? The resource is the chocolate. The spoils would be all the crumbs. And remember, chocolate with crumbs on it is ore. If you could peel off all the crumbs to expose perfect just chocolate, to go from dirty to clean, how many of you remember that, dirty to clean? The dirty chocolate chips are chocolate chip ore. When you take the crumbs off the chocolate, you get a clean chocolate chip, and you get tailings. They're the stuff you refine away from ore. Next, this bullet here. Everybody needs to explain acid mine drainage. We've discussed it a few different times by now. So let me just get a few facts that you need to have in your notes. I don't care how you say this, but you need to know something about this. There's no oxygen deep underground. So when you make a big hole, you're going to expose things to oxygen. ... Those things will oxidize. ... Plus water, when oxides get wet, you equal sign, what do you get? Oxides and water gives you acids. I don't care how you have this in your notes, but that concept is critical. No oxygen deep underground. When you make a hole, you expose to oxygen, ... oxidize, ... plus water equals acids. In other words, that big pile of spoils is going to make acid mine drainage, and that big pile of tailings is going to make acid mine drainage. Wherever you have the mining site and wherever you do the refining. Anybody want to ask me something?
Where is those that gas?
Okay, next. That's called impoundment. You have to hold that water because you can't just let it go into the environment. That's called impoundment. Like the way that stray dogs get put in the pound, you impound that stray water. You capture all that water, and ideally you evaporate it away until it's super concentrated, and then you treat it chemically to neutralize it.
Do you have like specific plan for that?
I don't know. Probably, I think so.
How do you like take that out of
Clay miners, drainage, like this is one of those impacts of mining that you just can't erase it. You'll never get it down to zero. Mines create an acid problem. Like you said, I mean, how are you going to get that out of the ground where it just soaks in whenever it rains? Like, you just can't. You can deal with it at places where it's convenient or available, but a lot of it gets away from you. This is a non-point pollution source. And the scale of these things is growing big time. So, here comes the 5 types of mining. Number 1 is called placer mining. It's when you dig up placer deposits. Keep writing. I'm going to add something into this slide. First of all, a placer deposit is what? What is a placer deposit?
Throwing water.
Heavy objects that left off in places slow down.
That's right. They are dense material that's been left behind as water slows down. Keep in mind, that can be in a river or where a river used to be. Past tense rivers can do this. Well, it sure looks a lot like you're copying one word from a cell phone. Crap! Fine. I take that back. I apologize. Crap. Okay, looks like Jose the Jackass. All right. I did get Tim doing that, and I have a photo of it. I did. Okay. Those placer deposits, they can be in a river now or where a river used to be. And so when you go playing around in there, you're going to put a lot of sediment into water. Basically, you can use fire hoses in a stream. You can excavate and sort with water. But when you've seen people gold panning for gold, that's what they're doing. They're separating stuff based on density. This is the gateway to deforestation. How many of you have heard that we're losing something like 7 football fields per second in Brazil, or whatever that number is? How many of you thought that that had something to do with logging because of all the trees and all that forest? Negative, 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 negative. In the tropics, the trees are usually soft. They're usually interwoven and tangled and hard to get out and hard to move and hard to shift. So here's how it happens. You get people carving out access to the forest for mining. That's always illegal. You're not allowed to do this. Because it's illegal, why not take some slave labor to do this? So one of the biggest stops on the global human slave trade is illegal tropical mining sites. You carve out a little space in the forest, you look for gold or diamonds or whatever you're trying to get out of there, and when your deposit is done, you pull out, leaving a road to a parking lot that becomes useful to hunt exotic animals, take bush meat, and as more and more people go through, you're starting to like increase and open up the access until we start mining and until we start ranching and grazing there, slash and burn, pull out a few trees, maybe a little bit of logging. But the gateway to deforestation is tropical mining. And it's always illegal, but it's hard to enforce laws out there. Something else you have to know that I'll explain later when I get to here is that this results in a lot of mercury pollution in rivers. The most mercury in water anywhere on the planet is in freshwater fish in the Amazon River. Remember how I told you biomagnification, top of the food web predators? Even worse is a lot of fish low on the food chain that live at exceedingly high mercury levels in the headwaters of the Amazon. When you think about placer mining, it used to be these guys, but that doesn't happen anymore. This is considered a teeny small scale hobbyist setup, but globally most placer mining is large scale. Dig up places where the river's been moved or where the river used to be historically, like in the tundra. You know, ice ages ago or between ice ages, the tundra had rivers flowing through it. Also the rainforest, all that water, you know that's going to separate sediment. That all has to come out of mountains somewhere. So as long as nobody's there to stop you, why not go big, set up mining camps, unfortunately using mercury sometimes, and sometimes make really, really large mines. This is considered black market mining, illegal mining. Some people call it guerrilla mining. This is not official, but about half the gold in the world today comes from illegal mines. Roughly half of our global gold supply. That's why I try so hard to get my gold recycled. This is recycled gold, trying to not contribute to primary gold. Another type is what you consider the classic type of mining, the Zoolander kind of mining. Say what? I have not. Is it good? You didn't get it.
It's not. It's not that good. It is. It's not that good.
He says it's out and he says it's not good. Your brother walked out and got his money back? Dang, dog. From someone who once worked at a variety of movie theaters,
I was in the business.
that's pretty rare. People never walk out and never try to get their money back when they do.
I do.
I mean,
James Bond was terrible.
What?
okay, anyway.
It was disappointing.
Shut up. The thing about the carts and the homies with the shovels and like the little tunnels, it's not like that anymore. The homie with the shovel has been replaced and so have the carts. The scale of mining has reduced humans and labor costs and increased efficiencies in production. This is how we get coal plus a lot of metals. On the left side of the screen, you can see the underground mining, as opposed to what we call surface mining on the right. Underground mining looks like this. You'll have a vein running through the rock. That was probably a sediment layer, but in uplifting became semi-vertical. You dig an elevator shaft and then horizontal tunnels to take out that vein. I'm sure you realize when you get to all of these complexities, that's pretty sketchy. We don't really do this anymore because it's so dangerous. So, yeah, that happens. So the only times that we really do underground mining is if the land is super valuable on top, or if you found like $1 million of gold underneath the White House. We're not going to nuke the White House, but we might dig a tunnel underneath it. I mean, the White House is probably a bad example, but you know what I mean. So what we do more of now is what's called open pit mining. These are big holes in the ground. This is the third type. Now we're talking a lot of stuff, just big old holes. Because you know, engineering has come a long way. We can make bigger shovels. So get ready for this. When I say that volumes have grown, I mean they've really grown. Whatever you're doing to visualize this, you probably can't. Like your brain can't handle numbers this big. That's about 3 miles across and almost a mile deep. In other words, that's further than from here to the ocean in diameter. That would go from the east side to the west side, basically all Santa Barbara, deeper than sea level by hundreds of feet. Many hundreds, 700 or so feet. Oh. Utah. This is what I mean by spoils. It's the dirt you move to get to the deposit down there. That deposit's worth, I don't know, a few $1 billion. So whatever, hundreds of millions to get to it is chump change. If you can spend $4 billion to get $5 billion, that's made $1 billion. It's probably worth it. So that's kind of what we do here.
Did they reclaim that land or no?
I don't know the exact numbers. When you look at those roads, remember that those are the access roads, but when you look at those roads, I want you to scale them to a little mining truck. And next, when you think about that mining truck looking down that road, don't forget that the mining truck is much, much bigger than my Tacoma. See what I mean? It's 2 lanes for mining truck, but that's like 6 lanes each way for Toyota Tacoma scale. Those mining trucks, you're thinking of toys from the Tonka days, but those mining trucks are really big. You see the little man in the front? He climbs a 2-story staircase to get to the control deck. So think about the size of that truck. Now think about the size of that road. Now imagine what kind of landscape you're looking at. Now imagine how many of those roads are in this image. You see what I mean about how our brains just can't scale this? Like you just can't. Don't feel bad. Our brains aren't built to handle big numbers. There was never 38 billion lions coming at you. Your brain can't do that. Pretty much, if it's more than 2 lions, you're screwed. So our brains are really good at single digits. Yeah. I know. Will you please stop the video?
Later.